So here's chapter 8. We're going to be talking about classes. So what are classes? Well, we can think of them in two different ways. A class is any brand new script that you make in your project. So the mover scripts we've made, the collision scripts, those can all be considered classes. Unity also has pre-made classes that contain all these functions that I've been introducing you to, like the vector class functions and maybe the debug.log function. Those all are contained within classes that Unity has already cooked up for us. So let's think of it as in metaphorical terms, going back to the assembly line in a factory. Alright, so if variables are boxes of products being produced, bits of data that we're trying to solve for, and functions are the machines that make these products, then classes are the factories that the machines live in. So we have the building, which is the class. We have the functions, which are the machines that exist on the assembly line. And our variables are just the products being made on it, if that makes any sense. Class is a way of collecting all kinds of behaviors. They can contain basically anything. They can even contain other derived classes. They can contain functions. And of course, they can contain variables. Classes are kind of ways to access functions and components like the GUI, transformations. Remember those vector 2D, vector 3D functions we were using. And then we have the mesh renderers that basically draw the objects on our screen for us. So I don't know if I've mentioned object-oriented programming before, but in short, it's a useful method of programming in which you can create many different factories or classes that all work together to make your industrial business or your game function more efficiently and with less confusion. So that basically means if we had a building over here and a building over here, this building made bottles for soda. You know, they blow the glass, they're just churning out bottles. And this building over here makes the bottle caps. So they're shaping the aluminum, they're melting it down, they're making casts. Basically, this building can function independently of this building because all they worry about are making bottles over here. All these guys are bottle caps rather over here. These guys only worry about making bottles. So whenever you have an industrial business, say like a soda manufacturer, you can have one building making the bottles, another building making the bottle caps, and then you can have your main industrial business pipeline combining these two. So object-oriented is just self-contained little classes or scripts doing their thing, and they can borrow elements from this class or this building, and it just is a kind of way to, I guess, modularize your production pipeline and your scripting. So in a programming world, you can have guys that only worry about enemy AI over here in this house right here. And then you can have guys that only work on programming the user interface. And then you can have guys that program putting it all together over here in the middle. So you can have, just separate teams working on their own thing. So let's look at some examples. So we have a class of a car, and we have a wheel array that contains 4 wheels. We have a public engine. So this is a variable that is a engine. And then what is this? Public float gas tank level. So here we have 3 different kind of things going on. We have an array of wheels. We have a new variable of type engine right here. And we have a float that controls our gas tank level. So this is just an example of saying that within my car, I have all these different things working together to get my car working. Directives, I just want to touch on that quickly. Remember when I said Unity has these pre-rolled classes? Well, libraries and directives, they're used to gain access of different variables or functions outside of your code, and Unity has the basics already built in for you. That's why you see that, let's open up this script I just made. That's why you see these first 2 lines up here. these are kind of calling on classes that are inherent and pretty much default inside of Unity. So that's what those two lines always mean right there. So I think that's it for the slides. So let's just get in and let's start seeing what we can do with classes. And this is going to be one of my favorite chapters in this semester. I'm going to unlock a whole new world for you guys. Because right now we've kind of been limited to only working within, you know, just our scripts here. I mean, I don't know if you guys have wondered how to do it yet, but how many times have you guys want to be able to access data from maybe the player fire and use it in your laser or missile or bullet classes or scripts right here? Well, in this lesson, we're going to see how we can pass data in and out of different classes. So I'm going to go ahead and I've created this example scene here, and if you've downloaded the assets for this chapter, you'll find all the work I'm about to do already made for you inside your prototype. But I'm going to remake it all from scratch so you can follow along and go step by step with the logic I use and how I'm doing all this stuff. So the first thing I want to do is just put some objects inside my scene. Here I'm just going to make a cube. I'll slide it maybe over here. And let's just make a sphere. And I'm just going to be using some basic primitives to get my point across. But I do want you to think of, let's get these on the right axis. I'm going to select both of these, get them both aligned on the z-axis. I want you to think of the cube, and I'll kind of scale it a little bit, as our spaceship player right there. And I want you to think of the sphere as our hazard. Alright? And before I can start programming, I'm going to go ahead and set my scene up with some components that we might need. So with my cube, I'm going to go ahead, and it's already got a collider on it. And this example is going to be dealing with how objects collide with other objects. So I'm going to go ahead and get that set up. I'm going to set this sphere, these colliders, and I'm going to mark the trigger, because we don't want them physically bumping up against each other. We want to be able to enter each other's collision boxes, and then we'll do a bunch of code whenever they do that. And let's go ahead and add some rigid bodies to them, and we'll turn off gravity. Same thing here, physics, rigid body. We'll turn off that gravity. Alright, so now we have colliders and we have rigid bodies. I want to go ahead and grab an asteroid mover and attach it to my sphere here. That way we can get my sphere traveling towards my box. And I'm just going to go ahead and set the speed to 1 over here inside my inspector in my asteroid mover class or script. And I want to name this sphere A. Alright, so the object of this exercise is going to be creating a new class that has stats for each of these objects. Stats like their health, if they have shields, how much damage they cause if they collide into another object, things of that nature. So when if you think about making stats for something, we definitely know we don't want these stats to be identical. So does that mean we're going to have to make a stat script for each object? No. I think we can get away with only making one stat script. So I'm going to go ahead and let's make our first script right here. I'm going to call this example stats. I don't know if I can get it spelled right. And it's going to be empty. And I'm going to go ahead and drag and drop them onto my game objects. So I dragged and dropped that one. I'm also just going to show you another way we can attach scripts again. I'm going to select sphere A. We'll go to add component. We'll go to scripts, and oh, there's my example scripts right there, and that just adds another component to my game object inside of my inspector panel. And as you'll see, there's nothing really going on with these with this example scripts. I'm going to collapse all these other components that aren't going to really be useful to me, just to clean up my inspector a little bit. I only want my example stats to show. Alright, so let's go ahead and flesh out my example stats class or script. I want you guys to start using that term kind of interchangeably at this point. We've been calling them scripts, but they also function as classes. Alright. So in my void start, well, why don't we go, actually we don't need any of these. I just need to declare some public variables. Alright. So why don't we go ahead and do that real quickly. So I'm going to make some public variables of type float. Let's make one for health. public float for my shield, public float for how much damage they cause, and let's just make a bool for is destroyed. You never know when that might come in handy. Whenever you make Boolean variables like this, think of them as flags that are either on or off. So if you ever need to flag something to be in one state or the other, a bool is a good way to do that. Example being, if I want to have a flag that tells Unity that an object is destroyed without actually destroying it, I can just check this Boolean on and off, if that makes any sense. So now when I select my cube, my inspector is updated with these blank variables here. And I want to point out something real quickly. If I change the health variable on my cube, my sphere health is independent. So I can get away with attaching a script or a class to each individual object here, and their variables are unique to that game object. So basically, if I set my health differently in my inspector, they'll both have different health, and if I press play, they still have their independent health values. But we don't want to do that in this example. I'm going to go ahead and set these back both to 0. We'll just leave them blank, like so. So how am I going to show how we can pass variables between classes? Well, why don't I make 2 more scripts, and we're going to call this let's call this my cube class, and I'll make another one and I'll call it my sphere class. And let's see, I'm going to open them up through my outliner right here. Those not where I want them. There we go. So I can open up scripts over here and mono-develop through this little outliner right here. So I'll just double click on cube class, and there's sphere class. And remember, we already have my example class. For all intents and purposes, my example stats right here, we're done with it. We just needed a class to declare some variables. We haven't even initialized them yet. They don't have any values. So I'll just leave this open for now, so in case I need to refer back to it. But I want to go ahead and let's get to work in my cube class here. So I want to accomplish 2 things here. First, the first thing I want to do is I want to, in void start, I want to initialize these variables. So whenever I press play, these variables will be assigned values. And I'm going to do it in my cube class, so they'll get their own unique values here. Alright, so what does that mean? Well, just work along and you'll get what I'm saying. The first thing we need to do is we need to create a local variable we can use within my cube class that can access this script right here, and therefore access these variables. So how do I create this local variable inside my cube class that I can use to reach to these variables right here? Alright, well, let's just do it one step at a time. The first thing we're going to type is we're going to give this local variable a type. Alright, so why don't we, and what type is it going to be? Is it going to be an int? Is it going to be a float? Well, in this case, we already have the types of my variables defined here. What we need to do now is we just need to define a type of variable that fills in for this class right here. So instead of typing int or anything like that, we're just going to type the name of the class that we want to get to. And this is basically the same thing as declaring it an int or a float. Remember, we're not declaring a variable that functions exactly like this health yet. We're just creating a local variable that points to this class. If that makes any sense. Hopefully it does. The program is a little weird. Sometimes you just have to go with it. So why don't we go ahead and call this variable just something generic like stats. So we've done 2 things right now. I've declared a variable called stats, and I've cast it of type example stats, which is basically the script right here. Now we need to initialize it. whenever we initialize it, basically we're telling Unity to, okay, we have this new local variable. We need to point to this class now. So this is where the heavy lifting comes for this variable declaration. All right, so let's take it step by step. We're going to type get component. All right, that's basically going to tell Unity to come over here in the inspector and start looking for all these components. Each one of these drop down expandable little submenus is a separate component inside of Unity for this specific game object. So what we're going to do is we're going to tell Unity, okay, look in these components, and which component do we want to access? We want to access example stats. So how do we type that? We've already told Unity to look in our inspector. Now we're going to use less than or greater than signs. We're going to open it up with this, and we're just going to type the name of the class that we want to access. And notice how this turns blue again. And we want to finish this off with parentheses. So now we have a local variable called stats that points to this class or this script right here. So what does that even mean? What can we do with this? Well, we can start initializing these values right here in my start. So it's pretty simple. We're just going to call stats. We're going to use a period, and you'll find something pretty funny here. You know how we have all these different options we can use? Well, if I get down to, whoa, wait a minute, health? Is that the same health that it's a float? Let's bring that back. Okay. It's already recognizing the variable I declared right here. So that's nice, right? So stats health, what is that going to equal? Well, my cube class, we're going to pretend is my main character, and a starting health of 100 is always kind of the status quo for video games, right? And I can do this for all of the variables I declared. Stat shield, let's give this a shield of 15. Stats damage caused. So this variable right here is going to be the value we use whenever things collide in my player ship. Basically, how much does my player cube here damage the other object I collide with? And let's say 50 points of damage. And we can even use booleans, remember? And we can set this equal to false, because we don't want to start out the game loop with is destroyed set to false, because obviously my cube hasn't been destroyed yet. So if we hit Control S and save, hopefully we don't get any errors, and we don't. And I want you to notice something right now. Before I press play, let's review what my values on my example stats. They're basically 0, right, for both my cube and my sphere right here. But if I press play, we're going to run this start function here, and you'll see firsthand how this local variable stats that we declared and initialized, and how we can access these variables, are going to change these values in my inspector. We'll press play, and nothing happened. Well, why is that? Have I saved yet? Hit Control S to save. There we go. What's going on here? Well, it's a rookie mistake. What do I need to do? Can anybody guess? It's going to be so simple. I need to attach my cube class to my cube. Yeah. Kind of shameful I did that, right? Well, that just goes to show you that weird, stupid things can hinder the process of your... Okay. I'll just press play, and now you'll see that my values now equal what they do. Alright, so that's just an example of initializing variables in one class that are declared in another class. So that's pretty cool, right? How we when we started typing the stats dot and it pulled up our health and shield for us automatically. So what can we do with this? Okay, how can we get it to work within our game and it be a meaningful way to work? Well, why don't we just set up a simple, if I press maybe the space bar or the 1 button, why don't we add 10 health to my ship? So it'll kind of be like collecting a health power up. Well, one thing you got to know about local variables, such as this one right here, they only exist within this function. So if I'm going to a totally new function, whether it be a void update or a void Ontriggerenter, I basically have to redeclare and initialize this local variable. And it's as simple as copy and pasting. Now I have the same local variable, but now it'll exist in my void update for me. Alright, so let's just create a simple if statement that checks for inputs. Input dot get key down, and we're going to look for key code. How about alpha 1? That's basically 1 on your numpad. And I'll just close out the parentheses correctly. Get rid of the auto formatting with Control Z. This is just the way I like to format my code. Really easily readable parentheses. You know, sometimes your code may get hard to read, and maybe sometimes it's because you don't have your indentions quite right. I find that careful indentation will always help you kind of keep your code in order so you can understand it a little bit better. Alright, so if I press 1 on my keyboard, what did I say I wanted to do? I wanted to add maybe 10 points of health to my player. So that's easy. Let's just say stats.health equal stats.health plus 10. And I'll hit Control S. We'll go back to my code. I'll select my cube. These variables are initialized. If I press 1, I get 110 health. Keep pressing 1, and now we're just adding to my health. I want you to take note that my sphere still has a blank slate on its stats. We haven't even touched the values of the stat script on my sphere. Again, I just want to reiterate that whenever I attach a generic stats class like this to separate game objects, those variables are unique to that game object. That's why sphere has no stats defined right now. But we can do a little bit better to this code right here. I don't want my player's health to go above 100. Alright? If a player picks up a health icon, I want it to cap out at 100 always. So what kind of stats can we use? Well, let's just make another if statement. Let's say if stats.health is less than or equal to 100, and meaning this first condition has to be true, as well as this next condition, stats.health is greater than 90. I might have read that wrong earlier. If I did, you know what I was trying to do. Let's just indent this over, get my formatting just right. There we go. If I put my cursor next to this bracket, it'll highlight its paired bracket. Alright, so if stats.health, if my health is less than or equal to 100 and greater than 90, this is the danger zone. You know, if we're increasing my health by 10, I don't want it to go over 100. So why don't we just set my stats.health. I'm just going to copy and paste this real quick because I'll probably need this in a second. Let's just set my stats.health, just cap it off at 100. And then we can just do a simple else that does the normal thing right here. Alright. So basically this just checks and see if my health is between 91 and 100. If I collect a health power up, then if these two things are true, it would have bumped my health over 100. So instead I'm just going to cap it out and set it absolutely at 100 right now. So that's if I hit Control S. Let's set my let's change my cube's initialization to 91 right here. And if I hit play, my cube's health is at 91. If I press 1, it should equal 101, but yet with that if statement I just capped it off at 100. So that's a little bit of programming some game mechanics into your game for you. So that's all well and good, you know. I figured out I can access components or classes by using this guy right here. But what happens, you know, the example I showed you is how you can access other components on the same game object right here. You know, we were only dealing with my cube, the stats on my cube. But what if I need to access scripts or variables on other game objects in my scene? Well, it's a little bit more complicated. We can't just use this get component. We have to describe what kind of game component we want to, or game object we want to get those components from. So I'll show an example of that on my sphere class right here. So let's do the same thing over here. Alright, why don't I just copy and paste this guy right here, and I can initialize right here. And since this is a hazard, why don't we set its health equal to 10? I want it to have 0 shields because hazards, I don't want my shields to have hazards, or my hazards to have shields. And how much damage does it cause? I just want it to cause 10 damage every time this hazard sphere collides into another player. Alright, so in our void update, I want to check for collisions now. Alright, basically what I'm going to program is every time this sphere bumps into my player, I want it to basically be destroyed based on how much damage my player is causing to the health of this sphere. So I'm going to have to look at my damage caused on my cube to see how it affects my health on my sphere. So basically we're going to have to access variables on another game object altogether. So let's see how we can do that. So we've kind of touched on collisions before. So let's just use our we don't want to do a void update actually. I'm going to get rid of that void update. Instead, I want to use a void Ontriggerenter function. Alright, so this function right here will always, the only thing that will happen, the only way this body of code right here will happen is if our objects collide with each other. So again, I'm going to have to declare another local variable right here. Because remember, our local variables only exist in the function that they're called in, or they're declared in rather. So I'm just going to go ahead and maybe copy and paste this. Alright, great. So now I have, well, there's a problem I'm going to foresee. If I'm going to be dealing with two different types of stats, maybe I should name my variable something else. And since this line of code looks at only this game object, meaning the sphere that we're attached to, I know that this sphere this local variable is going to talk to my sphere. So I'm going to call this sphere stats. That's going to be the variable we're going to use here, because we're just getting the component that exists on this game object. So now we have to be able to access our cube stats so we know how much damage it causes our sphere. There's a bit more to this, since this one has stats we want to access on a separate game object. So we're going to start with stats. And again, it's like casting the type of variable we want, like int or float health, for example. So it's going to look very similar to what we have here. So this is the type of variable. So let's go ahead and type example stats. Alright, because that is definitely, did I type it wrong? Let's see what we got going on here. And why don't we call this cube stats? Because these are the type of, this is the game object we want to access. We want to access my cube. So right now we have to tell Unity how to find my cube. We have to get the game object of my cube. And we can do this using my game object dot find game objects with tag. And let's say player. But you'll notice I haven't set my cube tag to player, so I'm going to go ahead and do that right now. So this line of code right here finds my cube game object. Now it's okay for me to get the component on my cube. So I'll just type period get component, and then example stats once more, close it out with a parentheses. And that's how we can basically declare a local and initialize a local variable in this case cube stats, that looks at my cube game object up there. Only thing different is it's the same line of code right here. We just had to add a bit of code right here that basically finds the game object that we want to get the components from. Alright, so there's that. Now we have two local variables that we can mess around with. So what kind of code do we want to do? Well, just like our old collision script, let's do a other object. Let's see. You know what I forgot to type in right here? I forgot to declare the collider local game object right here, or local variable. Let's call this other object. And this guy right here is going to be very important for the rest of the lecture. It's just a really nice way this function works on Ontriggerenter, because no matter what kind of object we collide with, whether it be a bullet, whether it be a hazard, whether it be the player, this other object right here is constantly changing depending on what we're colliding with. So if our player collides with a hazard, other object will point to that hazard game object we collide with. If a bullet hits an asteroid or a hazard, this other object will be the asteroid that we hit. Alright, so that's pretty important. We've used it before when we checked if the other object dot tag equaled. Remember this guy? Basically, we're checking what kind of tags we're hitting when we're colliding with each other. Should have been in a lesson or two ago. So in this code right here, we want to see if the asteroid is, or the sphere rather, our sphere is our asteroid in this case. We want to make sure we only do the kind of code we want to do if we're colliding with our player, which is our cube right here. So basically, we need to drop our sphere's health based on how much damage the cube causes. And it's nice because I already have a health variable and a damage caused variable that we've initialized within my cube. So we know my cube does 50 damage, but my cube only has 10 health. Well, that basically means we want the cube to be destroyed whenever we collide with, or we want the sphere to be destroyed rather whenever we collide with our player cube right here. So we need to drop our sphere's health. So let's just say sphere stats. Remember, I declared it right here and initialized it right there. Dot health are going to equal sphere stats dot health minus cube stats dot damage caused. And this line of code does what we want it does with the kind of stat computation, or the stat math that we want to do. But we're not quite done yet. If our sphere's health drops below the 0, then it should be destroyed, right? So why don't we add another little if statement nested within this guy right here. If our sphere stats dot health is less than or equal to 0, then let's do a few things. Let's set sphere stats dot is destroyed equal to true. And why don't we destroy game object? So this line of code will destroy the game object that this script is attached to, which is the sphere. So we hit Control S. Hopefully we don't get any errors. Right now we see that I don't have my sphere class attached yet. So there we have my sphere class. If I hit play, let me move this back a little bit. So we have my health and my damage initialized, and whenever we collide with, boom. That's because the damage caused on my cube right here just totally wiped out the health of my sphere right here. So that's great. We're already kind of using our variables declared in my stats class right here and initialized in each of my cube class and sphere class. This shows how we can get these two variables talking to each other. Alright, there's one more thing I want to show you guys in this example. And this is going to be the meat and potatoes of your assignment. There's a better way that we can check for collision and do the kind of math we want it to do. So I'm going to give that example inside of my cube class right here. I want to keep that update going. There's no need to get rid of it. And let's do another void on trigger enter. Alright, so what kind of code do we need to do here? Well, let's try another way of getting the stats of the object we're colliding with. So the first thing I need to make sure is I need to give this local variable. I need to declare this local variable right here. This other object is going to be really important with what we're doing. Because remember, anytime our object, which is in this case our cube, collides with another object, which in this case will be the sphere, this local variable that we just declared right here is always going to equal to what we collide with. So instead of using GameObject, find objects with tag player, instead of finding objects with our tag, our void on trigger enter already does it for us. We've already found what kind of game object we need to mess with because it sets it equal to this local variable right there. So, but first we still got to do that whole local variable thing for our cube itself. And in this case, I'm not going to change the name of stats right here. I'm going to keep it generic stats. A very generic name. We don't need to do anything else with it. Because we just need to access these guys right here. Alright? So, we figured out two ways in which we can declare local variables and access their components. This is just the standard way to access any component that exists on the same game object. And this is a way where we can set these local variables by using our game tag right here. But like I said, other objects are already doing a lot of work for us. So I'm just going to copy and paste this. And instead of calling this stats or cube stats or sphere stats, what if I just called it other stats? And I set it equal to other object dot get component. So what did we just do there? Well, we're still declaring or casting our local variable as example stats, which is found right here in this class. We're giving it a new name, the other stats, the other object we're colliding with. And instead of finding this game object with tag, we're just using our local collider variable right here. And then we're getting the component. And we want to look at the example stats component. So that's all we really need to do. So why is this powerful? Well, if you'll notice, these variable names are pretty generic, right? They can stand in for any type of game object that you got them connected to. And in fact, I believe that this way of handling how stats change when an object collides is probably the best method. You can use this method to make one collision script that can be applied to all the game objects in your scene. How do you do that? Well, stats right here will always point to whatever game object it's attached to. So in this case, in our cube class, it's always going to point to our cube. Alright? So if we attached the code to my sphere, then stats is going to point to the sphere. And why does it do that? Well, that's because we're just getting the component. We don't have any other type of code in front of get component. When we just have get component written right here, it knows to only look at the game object that the script is attached to. And then other stats right here will always point to whatever game object we just hit because of this guy right here. So in this way, we can interchange this code on any object. And when you do your assignment, your collision script that we had here, I'm just going to bring it up, is going to look a lot like what we're about to type right here. So this will no longer exist. we're going to use this game logic right here. So what do we want to do whenever something hits my cube here? And remember, my cube has a shield. It also has health. So what kind of cool game mechanic can we use with my shield and my health? Well, let's just write out the kind of logic we want to do. Alright? Let's just make some rules. And I'm just going to type them out. Rule number 1. Shields will take full damage from all sources. So meaning, whenever we hit an object or a sphere or a hazard, whatever you want to call them right now, shields will always take the full amount of damage caused, which in this case will always take 10. I'm just going to copy and paste that rule template. Rule number 2. When the player has shields, they only take half health damage. Meaning, whenever we get hit with spheres or asteroids or hazards, and we have shields, our shield will take full damage, but only take half damage to our health. Well, let's just type that right there. What's rule number 3? When the shield reaches 0 or below, maybe we can go into negative numbers in shields, then the player takes full health damage. So if we don't have any more shields, we're going to be getting the full amount of damage to our health right here. And of course, rule number 4, when the player has 0 health, they are destroyed. So using these 4 rules, let's go ahead and program the kind of logic we want to use to get that going. Alright, so let's just say that if my stats.shield, there we go, I'm having trouble typing today, is above 0, meaning if we have our shields, meaning if our shield value is greater than 0, then we want to take my stat shield and set its value to stats.shield minus other stats damage caused. And we want to set, we're going to take half damage to my health equals stats.health minus, and let's use a parentheses. Let's do other stats damage caused and divide that by 2. Alright, so basically we're going to look at how much damage my sphere causes, which is 10, and we're going to divide that value by 2, so that'll be 5. So that way we're only going to subtract 5 points from my health and the full 10 points from my shield. Alright, great. And let's just do an else statement right here. So else, that meaning if my shield is equal to or less than 0, but we don't have to write that because the else handles any other situation other than this comparison right here. We'll just do stats health, and I'm just going to copy and paste this guy right here, and instead of dividing it by 2, we're just going to do the full damage again. So I'm going to get rid of this parentheses. So this right here will take care of the first 3 rules. We need to do one more thing. If stats.health are less than or equal to 0, then we're going to do stats.isDestroyed equals true. And then we're going to destroy game object. So there we have it. We have now just programmed one of our first cool kind of interesting game mechanics with our shield guy right there. using these rules we kind of defined right here. So I'm going to hit Control S. Let's see, we have a parsing error. Line 50 or 36. So let's see what we did. Line 50. We have a space in between this comparative statement right here. I think that should be the reason. Yep. Gotta love syntax. So what's going to happen right now? Well, our cube and our sphere will have their values initialized. My sphere will travel to my player ship. It'll hit my player ship cube right here. It'll subtract the full amount from shields and half the amount from health. And the sphere will be destroyed. So if I hit play, you can see that I have with my sphere selected. Boom, it's destroyed. So what happens to my cube here? Why do I move that closer here? Let's look what happens to the values right here. So I have 91 health. Boom. I now have 5 shields because the full 10 damage was cost to it, but yet my health remained, not as destroyed. We only took away 5 hit points there. So why don't we set up something pretty cool here? Let's see how multiple spheres hit us. And when I duplicate this game object, guess what also gets duplicated? The example stats, the movers, all that good stuff that comes with it. And why don't we go into my cube here, and let's just set its value back to 100. Its health value back to 100. So if we hit play, well, let me space these out. I'll move this back. And we can see how my shield mechanic works in the process. So with my first sphere hitting my cube here, we get 5 shields left. Now we have no shields. And there we go. But what just happened? I think there might be a bug in my code. Let's see. Let's do some troubleshooting. So technically, I'm thinking that whenever the third sphere hits, there we go. It wasn't a bug. I don't know what happened there. So let's just see what happens again. We now have 5 health, 90 health, no more shields. The full 10 amount gets taken away from my health. So cool. So what I want you guys to do for your assignment is I want you to use the kind of stuff we've just been going over about passing values in between classes. The big thing change here is going to come to our collision class. We're going to use this game logic, or this code right here, almost word for word I would guess, inside of my collisions class. Okay? So I'm going to go ahead and bring up the solution for this week. I won't show you any of the code that I did for it, but I'll show you how the game should function. And then I'll give you a set of, maybe a to-do list on how we can get this code working so you're not so lost. So here we have the solution that I came up with loaded into Unity. And I'm going to go over a few different things that have changed and what I want you to accomplish. First, you'll notice that every prefab has a stat script attached. Okay? And you'll notice that something for like the bullet, it doesn't have any health or shields. It doesn't need it. But it does have damage caused, and it does have this ammo variable right here. I'm going to treat that as how much ammo that cost, because now instead of having separate ammo pools for all of my weapons, there's going to be one ammo pool, and all my various weapons such as bullets, lasers, or missiles are all going to have different ammo cost and different damage they cause. Alright, you'll notice my asteroid even has the stat script right here. And this collision script right here is what's going to change. So I'm not going to reveal it, but I am going to show you guys what I want y'all to accomplish. So I'm going to select my medium fighter right here. And here we have my player fire script. It no longer has an ammo count. My ammo count exists on my stat script right here. If I hit play, you notice that my bullets don't destroy the asteroid. immediately. My asteroids now have health, and they may take multiple bullets to destroy an asteroid. But yet, I still set the damage caused by my missiles to instantly destroy an asteroid. And you'll notice that my missiles cost 10 ammo instead of 1. My bullets cost 1. And you'll see I'm getting a low ammo message right here. If I press my laser, I don't have enough ammo to fire my laser, because my laser cost 20 ammo. So I have 20 ammo left. And now I have 17 because I fired 3 shots. If I press spacebar again, I get a message saying not enough ammo to fire this weapon, because I don't have 20 ammo. But I still can fire a missile. So now I have 7 ammo, but not enough to fire missiles anymore. So now I can only use... Oh, I just got hit. So now my shields read 40 and my health reads 95. I have one more for a burst shot. Boom. Low ammo. Not enough ammo to fire any more weapons. So I'm basically done this round. If I hit objects, my shields are taking most of the brunt. I have no more shields, so now I should be taking the full 10 damage from my asteroids. 65, 55, 45, 35, 15, boom, boom, and I'm destroyed. Alright, so what kind of steps do we need to take to get this done? Well, why don't you go ahead and look at these guys. You can read through it. I won't go through it word for word here, because I want you guys to be able to kind of do this on your own. But if you follow this list, kind of things you need to do to go through it, then you'll be okay. There are a few crazy things you may need to take into account. This guy right here. Whenever you use the general collision script that handles stuff like that, your bullets will collide with your player, and your bullets will be destroyed by your player ship, and bullets will take away from your own shields, and hazards will collide with each other. So if you use something like this, if you use, let me quit doing that. Something like this, where in our collision script, before we do any kind of code, we are going to use our tags. So if bullet and player right here, if they're both the game object equals that, and the other game object tag equals this, then we're just going to return out of our collision script, and we're not going to do any of the stats math, because we don't want our bullets to be hitting our own player ship, and we don't want our player ship hitting our bullets, and we don't want hazards to hit each other. So that might be the trickiest part of the assignment, but I've given you the code you need to use. You just need to have 3 different ones. Here's the first one you need to use, and there's 2 other ones you need to put in there, and you'll just have to change what tags you're looking for. Basically, we're just saying we don't want hazards to hit each other, we don't want bullets to hit players, we don't want players to hit bullets. Pretty easy, I think. Here's some extra credit. The player fire class. I talked about how instead of different ammo pools for each weapon, we want to pull out of the same ammo stat right here. Well, this is going to be a little bit hard, because we're going to have to mess with classes and functions within classes and passing data between all those. So I don't know if it's extra credit. I would say for full credit, because I don't know how I can give more than 100 in the grading system. Let's just say if you want a full 100, you're gonna have to hit these things. Otherwise, if you hit everything else by getting your collision set up right, that's a solid 95. You're gonna be getting an A on it. But if you want the full 100, try to figure out how to get your player fire class updated so it pulls out of the same ammo for your stats class on your player ship. Alright, I'll probably post these parameters up inside of your chapter for this week. So really, we're just using our classes to pass values in between different game objects, so we can add health to our game objects, so a single bullet doesn't destroy an asteroid. And now it's looking like more like a game, right? Every week we're getting closer and closer to a game. Alright, so you guys know what you need to do. If you have any questions, please email me. Thanks.